Hello everybody, today we are going to start a question number 2 of exercise 1.1. The question is that, so that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is some integer. So you have to prove it by using the Euclid's division lemma. And it is told about any positive odd integer. So first we take, let a be any positive odd integer. Then now we have to apply the Euclid's division lemma. So when we apply Euclid's division lemma, that means we must have two quantities. The already one quantity I have taken the small letter a, which represents your positive, any positive odd integer, and another quantity you have to take b. Then you write here, then by applying Euclid's division lemma for a, and one more quantity we need b, and that b will be 6. That number 6 is coming from the question only. From here only the number 6 common number is there in all the three expressions, and then that common number you have to take as b. So when you apply the Euclid's division lemma for the two numbers a, for a and b, that means we are going to divide these two numbers. Then after dividing two numbers we must get one quotient on remainder. Then that's why for these two numbers a and b, when you apply the Euclid's division lemma, then there exist two positive integers q and r, such that here a I am taking as dividend and b will be your divisor. So dividend equal to divisor, that is 6, the quotient plus remainder. And where remainder should be greater than 0 or maybe equal to 0, but always strictly less than the divisor, as I have told you earlier in the first video, that the remainder can be equal to 0 or can be greater than 0, but remainder should be always less than the divisor. Here divisor is your 6, so right here 6. So from this relation we have some values for r. So write here, therefore the possible values for r, possible values will be 0, 1, 2, 3, 4 or 5. These are the possible values for your r. So based on all these possible values of r, here we are having the r. Based of all these possible values of r, we will have different expressions for a. Right? Therefore a will be, if you put r equal to 0 here, a will be 6q, or if you put r equal to 1 here, then a will be your 6q plus 1, or if you put r equal to 2 here in place of 2 here, then a expression will be 6q plus 2. Then like that it will go on, a equal to 6q plus 3, or a equal to 6q plus 4, or a equal to 6q plus 5, because our last value is 5, so put last value is 5 here. So these are all expressions of a. These are the 1, 2, 3, 4, 5, 6 expressions are there for this a. And the a is what? A is your positive odd integer. So out of all these 6 expressions, this is a mixture of positive, these all expressions of a are the mixture of even and odd numbers, and question is based on your odd numbers. So you have to, out of all the 6 expressions, find which are your odd numbers. So see here, first is your a equal to 6q. Whatever q is there, if your 6 is even number, so when you multiply any number by even number, this will always give you even. this is your even number. So 6q is even. Now with here 6q is even. Now with any even number, if you add odd number, so this will give you odd. Again here you see 6q plus 6q is even, and a plus 2 also even, so this will be even. And here 6q plus 3, this will be your odd. 6q plus 4 even, 6q plus 5, this will be your odd. And therefore the expressions for A are 6q plus 1 or 6q plus 3 or 6q plus 5, which is already there in the question and we have proved it. Now question number 3 is very simple, and take question number 3 as your homework. Simply find the HCF between the two numbers, that will give you the answer of question number 3. So take question number 3 as your homework. Now question number 4 I will do. Question number 4, here also again you have to apply the Euclid's division lemma. So use Euclid's division lemma to show that the square of any positive integer is either of the form thrice m or thrice m plus 1 for some integer m. So here you have to use the Euclid division lemma to show the square of any positive integer is of the form 3m or 3m plus 1. So you have to use the Euclid division lemma. So take any positive integer as a. Let a be any positive integer, then by applying Euclid's division lemma for when you apply the Euclid division lemma, we must have two quantities. One is already a taken for a, and one will be your b. So b we take here as the number here 3 is there, we take here 3 for a and b equal to 3. Then there exists two positive integer q and r such that e equal to dividend equal divisor is 3, take here quotient q plus r remainder, and here remainder can be given 0 or equal to 0 but strictly less than the divisor is here, b is second divisor less than 3. So therefore the possible values of r are 0 or 1 or 2. These three possible values are there. Therefore your e will be what? Now apply these three values for r here in this expression of a. So therefore e equal to thrice q or e equal to thrice q plus 1 or equal to thrice q plus 2. So three expressions of a we have got. Now we have to think about square of a. Right, therefore squaring these expressions both sides we get, first square this first one, a square till thrice q square, so 9q square. Now the square of the positive integers must be in the form of thrice m or thrice m plus 1. So with here you can try this format thrice m. So this is a multiple of 3. Now when you write it as a multiple of 3, it will be 3 within bracket thrice q square So write is this is thrice. You can write here already A B letter is there. Then you can write here P, where P equal to thrice Q square. But here one letter is already given, that is M letter is already given, so better replace M here. So this will be your right here thrice M, where this M will be this part, 3Q square is your M. So see here this thrice M expression is coming here. First expression we have got here after squaring the first expression. Now second expression is 3A plus A equal to 3Q plus 1, or you write here A equal to thrice Q plus 1. Here also you have to square, both sides square, and right hand side it will be whole square. So this will be your 9QC square plus twice AB, that means 6Q plus B square means 1. And this you have to try to bring in this format, thrice M plus 1. So thrice M plus 1 is already here. Here's a plus 1 already there. And this portion you have to write as thrice M. So from here, from the first two terms you take 3 common. So 3Q square plus twice Q plus 1 will be outside. So this portion you take as M. So thrice M plus 1, where M is your thrice Q square plus twice Q. So from the second expression after squaring A, I have got this thrice M plus 1. Now the third expression is left, or A equal to thrice Q plus 2, and both side you square, right hand side a whole square. So this will be 9Q square plus 12Q plus 4. So this you have to write as in the form of thrice M plus 1. As you need plus 1, so what you do, this 4, you have to break this 4 as 3 plus 1. So 9Q square plus 12Q plus 3 plus 1. So plus 1 will remain aside out of the bracket, and inside bracket I'll write all these 3 terms, and from these 3 terms I'll take 3 common. So take 3 common, the inside the bracket will be 3Q square plus 4Q plus 1, and outside it will be 1. So inside the bracket this portion you assume as M. So it will be 3M plus 1. So this is coming in this format, 3M plus 1. So where M equal to thrice Q square plus 4Q plus 1. So this is a question number 4. And question number 5 also you do as your homework. But in question number 5, in place of B, better you take as 3. In question number 3, in question number 5 also you will get expressions of A like this. Many will be there more than this. But in question number 5 you have to cube both sides. Here we are squaring according to the question, but in question number 5 you have to cube as per instruction. You have to cube, make the cube both sides, and then you will have to get the required expressions, and in all those expressions, to get those expressions better, in place of B you take 3, and if you take 3 then also you will get your answers, and which will be very comfortable for you. So let's remember, for B you take 3 in question number 5. Now I will do an extra question for you which was given last class. The question was that prove that n square plus n is divisible by 2 for every positive integer n. So right here we know that every positive integer can be written as twice q or twice q plus 1. This I can write. This is already given in your textbook example. Please you consult the example sums, there only you can find this. So any positive integers can be written in the form of twice q or twice q plus 1. Then here the positive integer, therefore n can be twice q or twice q plus 1. So there are two possible expressions for your n. So there will be two cases. So we write here case 1. For n equal to twice q, and you have to prove that this n square plus n is divisible by 2. So therefore n square plus n equal to n plus 1. The n place of n you write twice q, and here you write twice q plus 1. So now write twice q within bracket twice q plus 1, and this you can take as twice m. So this expression is expressed as a multiple of 2. So if any number is a multiple of 2, then we can say that the number is divisible by 2. So this n square plus n also is expressed as a multiple of 2. Therefore this n square plus n is divisible by 2. So therefore n square plus n is divisible by 2. Right here, where m equal to q within bracket twice q plus 1. Then you write case 2. For n equal to twice q plus 1. Therefore n square plus n equal to n plus 1. N means here twice q plus 1, and here twice q plus 2. So from the second factor I can take 2 common. So twice q plus 1, then q plus 1. So here also this I can write as twice m, where m equal to twice q plus 1, q plus 1. So here also n square plus n is expressed as a multiple of 2. So therefore you can say that n square plus n is divisible by 2. Okay. Next one, homework you take. That n square minus n is divisible by 2 for any positive integer n. And few more sums I'll give you homework in the WhatsApp. Okay, then thank you very much. Until then, goodbye.